Hi, everyone. Welcome to the Power Hungry Podcast. I'm Robert Bryce. On this podcast, we talk about energy, power, innovation, and politics. And I'm pleased to welcome Karl Meeusen. Karl Meeusen. He is the Director of Markets, Legislative, and Regulatory Policy at Wärtsilä, which is a very large Finland-based engine producer. Karl, welcome to the Power Hungry Podcast.
Thank you, Robert. It's great to be here today. I really appreciate your time.
Now, I didn't warn you because sometimes I ambush the guests. Guests introduce themselves. I've introduced you as the Director of Markets, Legislative, and Regulatory Policy at Wärtsilä. What does that mean? Imagine you've arrived somewhere and you have a minute to introduce yourself. Please introduce yourself.
Great. Thanks. So basically it means I serve two roles for Wärtsilä. First, obviously, is the Legislative and Regulatory Policy. That's helping to engage with regulators and legislators, help them understand what it is we do as a company and our technology solutions. Because what we find is that, by and large, regulators and policymakers are familiar with other technologies, and engines are a unique bird out there in the energy world. And so we like to help make them aware of things. The market's perspective is looking at two pieces of the market. One is how our technologies fit into some of the markets out there, ERCOT, SPP, MISO, CAISO, as well as trying to identify where our engines are good fits for potential customers. So we look at where there's a lot of price variability, where renewables are coming in, and there's opportunity where flexibility is really needed. So identifying those and help identifying those for the company.
Gotcha. Okay. So I did name Wärtsilä as a Finnish company. My familiarity with Wärtsilä was as an engine producer, a producer of very large engines for container ships. But the reason I wanted to talk with you is Wärtsilä recently struck a deal with the Lower Colorado River Authority, which of course is based here in Austin, for 190 megawatts of power plants as peaking power. But bring us up to date on Wärtsilä as a corporate entity, how old it is, and your main business is making big honking engines. Am I saying it too bluntly there?
No, I think big honking engines is the technical term, Robert. So there's three things that we're working on. First, obviously, yes, the big engines for the container ships and the cruise liners. That was kind of the origin of our engines from the onset of that part of it, but also for the engine power plants, where what we realized sometime about 20, 30 years ago was, wow, we're producing a lot of power and electricity for these big ships. What if we were to bring that to the land? What could we do on land with that same technology? The other thing we've gotten into a bit more recently is the battery storage systems and battery storage solutions. So when I think of Wärtsilä now from an energy standpoint, I think of us as the one-stop shop for all your flexible generation needs. The engine power plants have an extraordinary flexibility, ramping, starts, stops. We can get into that a little bit more detail down the road, but also obviously the inverter-based battery systems that we provide similar flexibility. So in a world where we're seeing now renewables are coming, whether we've asked for them or whether they're just showing up, again, that's kind of an irrelevant question. The more relevant question is, what do we do? How do we help manage them? How do we help balance those? So when you mentioned LCRA, you mentioned peakers. I like to think of the technologies we offer, especially the engine power plants, as kind of peaker plus, which is we can do a little bit more than your typical peaking resource would.
So let's talk about those engines because people not familiar with the Lower Colorado River Authority. They manage several hydropower plants on the Colorado River. That's the Texas Colorado, separate, of course, from the one that flows into the Bay of into Baja. But this entity was formed, I guess, in the 30s. They own power plants as well. They own, of course, the Fayette plant, which is a coal-fired power plant, and gas-fired power plants. But it was interesting. I knew of Wärtsilä before, and this is 190 megawatts, and you're using the 50 SG engine. So I looked it up, 377 tons. 18 meters long, and each engine is it's multiple engines, each of them producing about 18.5 megawatts. I mean, these are These are
big
monster,
honking engines.
big, big honking engines. Yes,
Yeah.
and they're going to be fired with natural gas.
Yes.
So tell me why these engines are finding favor as peakers now. How do they compare with gas turbines?
So if you're looking at a pure gas turbine with the heat rate somewhere up around 10,000, give or take, usually a little bit higher, our engines are running at heat rates closer to about 82 to 8,500. So our efficiencies are very good relative to some of those peaking resources, which is, again, one of the reasons I can call it peaking plus, which is if you need to run it a little bit more frequently at a base load, that thermal efficiency that we offer at that lower heat rate is going to get you a more affordable, more effective output. Beyond that, when we look at what a peaking resource is going to be doing, it's coming in at about 2 o'clock in the afternoon, maybe run until about 6 or 7 p.m. Single start type of resource. We've talked a little bit, and I mentioned, the variability in the system. Texas is becoming one of the largest renewable producing states in the U.S. And again, it's not a matter of whether Texas asked for them to come; they are there. And so in that instance, what you see is the need not to just run at a single output, which a lot of peaking resources, you turn them on and they just run flat out for about 4 hours at about 50 megawatts, give or take. And it's not a start-stop type resource. With the variability, ramping up, ramping down, starting and stopping is a much more critical attribute that the engines bring to the marketplace to really help any customers try and balance and hedge price risks.
So to be clear, these are the old Otto cycle engines, right? This is the technology that was first developed by an inventor named Otto, and I think was first patented in 1862. Now we're here. How many is that? 170 years later. I mean, it's a remarkably durable form of energy conversion.
Mm-hmm.
You warned me before we started, well, I'm not an engineer, but nevertheless, these are, I mean, you've talked about the fact already that the thermal efficiency of these, which are, I mean, if, for people who don't understand it, they're really just oversized car engines, right? There's very similar to what the engine in your automobile, and yet supersized here. So is it surprising to you? I mean, you think about the technology, how durable it's been, and how you've been able to achieve these increases in efficiency over time?
It is kind of fascinating to me that, when I first came to Wärtsilä about 2 years ago, it was kind of looking around and saying what's old is new again. It's bringing back things and technologies and using solutions that we've had out there and realizing the different capabilities and attributes and value propositions that they bring to the market. Again, in a world where base load, mid range, and peaking was your diverse portfolio definition. Flexibility and the ability to ramp quickly was not necessarily a huge value proposition. But I think what we're seeing now with the greater variability, where prices are swinging hundreds of megawatts in 5, 10, 15-minute intervals, having the ability to have a technology that's fast enough to chase price spikes and get offline when prices come back to normal is really valuable. We've been doing a lot of studies recently trying to assess what that value proposition for 5-minute capability is. So instead of looking at, well, let's do an hour-long interval plan for the next 20 years, you really miss the benefits of, I captured that price spike and helped mitigate that price spike for a customer. And when prices dropped, I didn't have to stay online and have them incur costs. And we're seeing some pretty staggering numbers. We think it's one of the big reasons LCRA, when they were looking at technology options out there, saw the value of that 5-minute capability, that dispatch on-off capability.
So what was the value? That contract was announced in February. What's the value of that contract?
Unfortunately, that contract value is confidential information. We're not allowed to send that one out right now.
Okay, but if I wanted to come to Wärtsilä and I needed a megawatt or 10 megawatts of new capacity, and I wanted, or well, your 50 SG is about 18 megawatts. So say I wanted to buy 20 megawatts, 18 megawatts of capacity from Wärtsilä, what would it cost me?
So the interesting thing about the technology we offer, Robert, is that it's very scalable and modular. So you got 18 megawatts, and you can build all the, plant to support 18 megawatts, and I can, come up with a number for you. But when you move to 36 and to, 64 and those larger increments where you're spreading that bulk of plant over more megawatts, those costs come down really quickly to the point where, we are still talking a little bit over, we're over $1,000 per kW coming online. But again, when we looked at our studies thinking about what those energy market revenues are, we looked at, for example, one node in SPP, and over a 20-year horizon found an additional $93 million worth of market revenues that can be attained just from being 5-minute dispatchable. We've looked at nodes in Texas and showed that, when comparing to a heavy-duty gas turbine, that you're going to capture significant benefits again from that 5-minute market. So when we look at cost, or when we think about cost, we try and think about more than just the installed cost or even a levelized cost of energy. It's really thinking about how does this resource fit within your portfolio, and how do you make the best next investment for your ratepayers and customers. And when it's really about capturing and avoiding capturing market revenues or avoiding market costs, we do that exceptionally for our customers.
So what I hear you saying is the installed cost now, the rule of thumb, as I recall, for natural gas turbines can be brought online in the neighborhood of $1,000 a kilowatt, $1 million a megawatt, something like that, right?
Yeah.
So you're saying that these 50 SG engines are in that neighborhood, but I'm going to read back what I've heard you say is that the difference is you can ramp up and down faster than the gas turbines.
And I think not only can we ramp up and down, at least comparably, probably a little bit faster than some of the other benefits is we can go offline and come back online much more quickly. Starts and stops for us are much less costly because, again, our minimum operating levels are a couple megawatts per engine. So if you've got that 190 megawatt plant, we can run that as low as 3 to 5 megawatts, as opposed to trying to ramp up a single source up to 150 megawatts. So we're only producing as much energy as you absolutely need, and then we can get back offline as quickly. So there's not an excess production from our technologies.
So that LCRA plant, where is it going to be located?
I think they've just chosen the property for that one, Robert, and I don't have that information off the top of my head.
Okay, but it's going to be about 10 of these 50 SG engines then, right?
Yep.
So if they need 190 megawatts or nearly 200, they can turn them all on, or if they need half that, they can turn on half of them. So you have a more modular offering in terms of the scalability, or the scale of the response to the peaks can be then scaled to whatever the demand is at that given moment.
Whether it's a local peak, meaning if we happen to see a price spike in a 5-minute interval, we can get to that as high as they need it to go, or the daytime peaks, summer peaks, we can get to that as well. Another benefit of the engines, particularly when you're talking about summer peaks, is that 190 megawatts in those Texas summers. It's going to be 190 megawatts. There's not a thermal derate. The cooling system for those resources is radiator cooled. They joke around at Wärtsilä and say that the operators will use more water in the toilets than the engines will use in the radiators in a given day.
Well, it's interesting. It's one of the things that I thought was interesting here, because this has been one of the criticisms of big power plants, right? Both coal and big thermal plants, coal and nuclear. Last summer, as I recall, in France, there were problems in operating some of the nuclear plants because they need big water intakes, right? They need a lot of water. So, but again, the car engine comparison is very similar here, where you don't have to put water in your car. It runs off the antifreeze in the radiator is the cooling mechanism. And so that is one of the other selling points. You can put these pretty much anywhere. You don't have to be near a lake or have some big water resource for cooling, because you're using air cooling through the heat exchanger, the radiator, right? To manage your thermal load.
Yeah. And again, it's an additional cost that we're working on calculating, what is the water cost savings? I mean, obviously that's going to depend on where you are and what, that water is going to cost to consume and buy and to utilize. But again, that's just another benefit in terms of both operational and cost standpoint. Again, when you're putting that in a Texas summer and temperatures are pushing 100 plus, there's no thermal derates on these engines, or at least very minimal, even up to 100 degrees. you're not looking at a thermal derate or need to cool them beyond just the regular cooling system. So it is additional benefits of you're building 190 megawatts to get 190 megawatts.
Well, it's interesting you say that, because the thing that pops in my head is that solar panels, their power output degrades as it gets hotter, right? They're not as efficient.
Yeah. Yeah. I mean, they'll degrade based on age, solar radiation, how many birds are flying over in a given month, and when
clouds, etc. So let's talk about heat rate and why it's important. Now you said about 10,000 BTUs for a gas peaker plant, but combined cycle plants, as I recall, run at like a 7,000 heat rate, something like that. So, and I looked it up. I think you said they were at about the 50 SG is about an 8,000 BTU per kilowatt hour heat rate,
between
something
82 and 85.
8,200 to 8,500 BTUs per kilowatt hour.
Yep.
Right. And online it has it in SI units. Was it 7,200 kilojoules? Which, it would be the kilojoules to BTU is not quite 1-to-1, but nevertheless it's in the same neighborhood. So, but do you have the ability to use the thermal offtake then to improve the efficiency? I've seen something about that you can. It's not a combined cycle technology, but could you in theory capture some of the heat off of these engines and use it for another purpose?
It's not a combined cycle. I have seen instances where they use them for combined heat and power.
All right, that was the term I was looking for.
Yep, like a CHP. You can do that. I'm not as familiar with some of the instances where we have used them for CHP, but I know that originally, as the engines were coming in, that was one of the big benefits, was you could capture the residual heat for heating purposes. You're not going to get additional energy production out of them at this point.
Right. And I also saw there was a difference in efficiencies, whether you run them at 50 for power gen, whether at 50 hertz or 60 hertz. And I don't quite know why that was. Did you?
That's an engineer's question about whether or not you're running in Europe or America, and I'm not exactly sure why they're going to get a different efficiency at those different hertz. But I've heard a similar thing, Robert, and I apologize for not being able to answer that.
Right, no problem. So how it seems like, I've heard of, I know that similar projects were deployed in Mexico by an independent power producer there in Monterrey. How quickly is this part of Wärtsilä's business growing? This part of the power sector business. What's the business been like there? I know you're recently hired on 2 years ago. How's I guess I'm asking the question. How's business?
Business is booming. Last year we were over 500 megawatts of sales intake for North America, and I guess I should specify U.S. We are seeing a lot more interest. People are asking a lot more questions because I think we've been very effective with getting our names out there a little bit more. Again, letting people know when you used to see an RFP come out of a planning process, the words used to say, we're looking for X megawatts of turbines and blah, blah, blah. And we're seeing the shift to all source RFPs. We're seeing a recognition and a lot more questions when we step out into places like, wait, who are you and what do you do? And people really curious and digging into the technologies and all the benefits that we bring to balancing renewables, providing reliable output. I came on just after Winter Storm Uri, which, impacted millions of Texans. And the thing that I really take a lot of pride in as a Wärtsilä employee is South Texas Electric Cooperative runs 2 of our power plants, and they were running through Winter Storm Uri. Helping, maintain some reliability and stability for their customers. Because again, when the pipeline pressures were dropping across Texas, our engines are operating at much, much lower gas pipeline pressure. So we don't need additional pressurization. We're pulling out, I think, 70 to 90 PSI out of that pipeline, as opposed to the 300 or 400 that other technologies are going to have to pull that out or more. So we're still running on those low pipeline pressures when they're just kind of eking by.
So tell me about the fuel supply then. Can you switch these? Because this has been an issue in Texas of having on-site fuel. And
Yep.
when Rick Perry was Secretary of Energy, he pushed a regulation, or FERC considered one, I think, that would have given some incentives to have on-site fuel. And this is the ultimate in energy security. You know where the energy is. You don't have to bring it in by pipeline or truck or something. It's on site. So will these power plants, can you switch them off gas and put them on diesel? What's the capability for that?
Absolutely. So I think the two cases I like to talk about on this one is in Humboldt, California. There's transmission challenges out there. Single line of transmission and single pipeline out to that area. And when California has some of the wildfires, they'll turn off those transmission lines, and Humboldt has to go into island mode. Well, the Humboldt generating station is a Wärtsilä supplied engines. It's running on dual fuel. So we've talked about the 50 SGs, that's the spark gas. We also have the 50 DFs, which is the dual fuel. So they do have on-site diesel capability. So if they have to go into island mode, they've got that source of fuel online and can maintain reliability up in that transmission islanded area. The other one is I won't mention specific names, but there's a military base in Hawaii that is running Wärtsilä engines on a DF basis. The primary operation is natural gas, but if the military base needs to go into island mode again, it's running on 100% local biodiesel. So again, it can switch these fuels on the fly. As long as you're talking liquid fuels, it can do it without even turning the engine on.
So, well, that's interesting. So then you have the DF, then it's a combined, I guess, a diesel cycle and an auto cycle engine then. So you have spark ignition and the ability to do compression ignition in the same engine.
Yeah, there's some different setups and specifications that they do for the engines on how they fire, but yeah, we can specify the engines to do dual fuel capability.
And is that the same output that you said, the 50 SG and the 50 DF? They're both about 18 megawatts then, both designs?
I think it comes down just a little bit on that one, Robert, but not a lot.
So where are they made? Where do you make? It's interesting to come back to Wärtsilä because I wrote about the company. In fact, I have a photo in my fourth book, Power Hungry, of a big Wärtsilä engine. Now that book came out 13 years ago. So I've been familiar with your company for a while. As I recall, that one was being made in Japan. Where are your manufacturing facilities located?
Recently, we opened a state-of-the-art manufacturing facility in Vaasa, Finland. So if you think about where Helsinki is and just head northwest, Vaasa is just on the northern side of Finland. That's where the vast majority of our engines are made. We were doing some in Italy a little while ago, but again, we've just opened this new plant, state-of-the-art, to produce our engines at now.
So was I wrong then? It's not being produced in Japan, or maybe
I think at one point in time we had other manufacturing plants around the world, Robert. But again, I will concede ignorance on the deep 180-year plus history of the company.
And so, how different are these engines, this 50 SG, from what goes into a container ship or into a passenger cruise liner? How different are they?
Not vastly, honestly. The nice thing about having both of those business units under the same heading is that we get to learn from each other. So yeah, they're going to mount them differently, and there's going to be some different methods on how we do the radiator cooling versus using some of the water from the marine sector. But by and large, they're utilizing similar technologies. Things we learn in the marine industry are things that we can turn over and say, okay, how can we apply that into the engine power plant sector? And so it's really great for synergistic learning. So, for example, right now, one of the other big pushes is, what are you doing with future fuels? How are you thinking about these fossil-based technologies? We've got the engines in the marine sector working on methanol and ethanol. We just ran a pilot up in Michigan with WEC and tested pure hydrogen blended into the engines and field systems, 25%. And we get to feed these back into the other sectors, so and learn from each other. It's really a great place to have that knowledge base kind of feeding each other.
Well, I was going to ask you about, you beat me to it because I saw that announcement about the hydrogen blending. So that was 25% hydrogen, 75% methane. Then is that right?
Yes, that's correct.
So what are the challenges then? Is there I know you said you're not an engineer, you're a sales guy, right? Or a regulatory guy. But what's the challenge in adding hydrogen? Is it more heat inside the combustion cycle? What is the difference there?
It is a more volatile combustion cycle. So it has different corrosive reactions to some of the metals. Again, some of the similar things you're going to see with, whether or not you want to put hydrogen into your natural gas pipeline systems. But the biggest challenge right now with some of these additional fuels is just simply getting a supply chain going for them and having a distribution network for them. For this one, we literally brought in a truck with the hydrogen in it and connected that system to the engine with, frankly, minimal modifications to the engine to get it really up and going. They did make some minor tweaks along through the operational interval, but everything ran beautifully for the engine. No, carbon emissions were down. Thermal efficiency was minimally degraded because, again, it's more volatile but less energy dense element. So there is, again, anybody that's burning hydrogen, you're going to lose some of that energy punch. But by and large, that pilot ran as well as we ever could have hoped. And I think the output from EPRI and WEC have said volumes about how well that went and how impressed they were with our technology during that pilot.
Well, so was that, you made that point just now, but that the fuel itself has less energy density, right? Depending on, of course, on the pressure that's applied, but in terms of the scale or the volume, energy density by volume. But was that why I just saw that when it was running, when the engine was tested with 25% hydrogen, it ran at 95% load, cutting it to 17%, you got 100% load. Was that due to that energy density, or do you know why that change in the output was so different from the different concentrations?
I think as an initial pilot, Robert, there was not a goal of really pushing to see what a maximum 100% load would do. We were very comfortable at that 95% load and a 25% blend. Again, right now we're at 25% primarily because of safety questions. Trying to understand how this works in the field. We've done greater than 25% in the laboratory. But again, when you're out in the field where not everything is that perfect laboratory space and you have some differences there, you want to take a bit more cautious approach. And so that's one of the reasons why we're at 25%.
Gotcha. So who are your biggest competitors now then in this? We could talk about batteries, but I think that's kind of a separate business. I mean, in the combustion peaking or even baseload generation, because I know your engines are used for baseload in some applications as well. Who are your biggest competitors? General Electric, Siemens? Who do you compete with?
I think that's where we see ourselves going forward, Robert, really is, if you're going to try and integrate into a system, you got to figure out, obviously GE's the 500-pound gorilla in the room. But I think the technology we bring to the table is really well suited for the needs of the system going forward. So again, if you're seeing ramping issues because you can't really get a resource online in time, or wind and solar are dying off quicker than you expected, you need something that can come online and be responsive as often as you need it, whether that's at 9 o'clock in the morning, 2 in the afternoon, or 11 o'clock at night, without limitations for some of those minimum startup times and minimum downtimes. That's something that our technology is bringing in spades. I think about it as, when you have a renewable system or variable system, I think it's maybe a better way of talking about it. You don't want fast start resources. That's just not enough. You want fast start, fast stop, fast restart resources. And I think that's where we really excel, is online in under 5 minutes, offline in 30 seconds, and back online in 5 minutes after that. That's exactly what an ERCOT or a system operator like that is going to need as you get a more variable, volatile system.
So, well, I'm going to read that back to you. Then, is it fair to say that the increasing variability or the increasing transient nature of the fuel energy supplies onto the grid are fueling your business to a large degree? That increasing variability due to the influx of renewables is leading to more demand for products like yours.
I think so. I think that's fair. I think that's part of what we've seen, as well as in the battery systems. That was a driving force in, for example, California, when you look to balance them out and extend some of the solar into later parts of the day. But that variability, that fast ramping, fast balancing type technologies is yeah, in by and large, supported and helped by trying to move to, or when systems move to a more variable system.
Right. Well, and I've seen Wärtsilä, what do they call it? The path to 100 or road to 100, that you can support that. And we haven't talked much about your batteries. What kind of chemistry are you using in your batteries?
Chemistry in batteries is lithium ion technology right now, but the
Lithium iron phosphate, or what, do you know the chemistry there?
I'm not specifically familiar with all the chemistry on that one.
Okay.
But beyond that, Robert, I think one of the other things that we've got with the batteries is the optimization software is state of the art, top of the line, called GEMS, which allows our batteries to work with whatever system you want to put them into, whether you want to hybridize them with wind or solar resource, or run them autonomously in the system, to try and help the customer maximize the return on that investment. So again, pairing a tool that is really designed to help you use the batteries more effectively, with the batteries that we're providing as well. So you get a really good bang for your buck out of the battery systems we provide.
So how's your deployment or sales of your engines compared to your battery deployments? Are you doing more engines than batteries? Is it 2 to 1, 5 to 1? How compare that sales or that deployment in terms of megawatts?
I don't have the specific numbers on our batteries from last year, but I think they're very comparable. We may be doing a little bit more battery sales in terms of megawatts. The megawatt hour durations differ from the two, obviously, because again, the batteries are duration limited. But I don't have the specific numbers as far as what our battery sales are from last year.
Gotcha. So you also said, so you did 500 megawatts of engine sales last year. Will you do more than that this year?
We fully expect to, you bet.
And what about the battery sales? And where are your best markets in the US for these?
Yeah. So we expect our batteries are going to be increasing and selling more of those as well. The best markets, as with anything variable, we're looking and building down in Texas. There was a recent announcement on a battery storage sale down there that we were involved with, as well as we've had some good sales in California as well as Hawaii.
Gotcha. And in Hawaii, that's batteries, or is that engines?
That's batteries.
I see. Because Hawaii just recently shut down their last coal-fired power plant as well, right? That's so. Have you sold engines in Hawaii as well?
As I mentioned earlier, we have one on one of the major military bases down there.
Oh, right.
As well as we have one. Kauai Electric has been running, I think, a Wärtsilä engine for, I think, 20 to 30 years. They've been running that thing.
Oh, that's right. Yeah.
The other place, like when you look at islands as well, you can go down to the Caribbean. That's a place where Wärtsilä engines are very dominant. We can withstand the hurricanes that the Caribbean throws at us, as well as right sizing the generation output to what the island needs.
So we've been talking about the 50 SG, which is 18 megawatts. So what are your smallest? Well, walk me through your product line here. You're the sales guy, right? So give me what it was smallest to largest. What's if I know islands, some islands are small, some are big. What is the range and output of your power sector engines?
So our two primary engines our smaller one is 9 megawatts. Our larger one is 18. Battery systems obviously can be built to size and scale of whatever the customer is looking for. So again, you can buy, we talked earlier about you wanted to buy one 50 SG, 18 megawatts. You can stack these like Legos, not up, but sideways. In the sense that, if you need 18, or if you need 1, 2, 3, 4, 5 engines, you can bring them in, expand the system as you need to. So again, it's easily expandable. And just buy the right number of megawatts for you. You're not going to look there and say, well, I've got a 100 megawatt or 50 megawatt system. I don't need to buy a 100 megawatt resource to fill that. I need maybe 350 SGs, and I'll have some residual reserve capacity for planning purposes or contingencies.
Right. So repeat it back to you. You have two building blocks, one that's 9 and the other's 18. Yep. Right. So below 9, then you're seeding that market, or I'm just not participating in that market, but other companies like Caterpillar or I don't know, some of the other companies that produce gen sets that are going to be smaller than 9 megawatts. You're not going to play in that area, which
No,
is
I mean, unless they're looking for our batteries, 9 megawatts is the smallest engine we're building these days.
okay. So you said you've been at Wärtsilä for 2 years. Where were you before this? You were in the power sector as well. Let me see. I'm reading you worked at CAISO in California. Then I assume you worked out there, so you know the California market. And then where were you working before you were at Wärtsilä?
So I spent 10 years at CAISO doing resource adequacy system planning for them, working on trying to think about what the system needed to get to 33, 50, and then 100% renewable targets. So I spent 10 years doing that. And before that, I was working at the Public Utilities Commission in California, helping set those goals. So, once we got the goals set and got renewable targets set, then it was time to go figure out how to actually do those. Once we got our head around how to do them, I thought it was time to get out there and try and help get those solutions in place.
So, well, since you've worked in California, how hard is the permitting battle out there? I've heard many stories about permitting for any kind of large infrastructure. And I've said before and written many times, the transmission grid we have is the transmission grid we're going to have. Can you talk a little bit, since you're a veteran of CAISO, can California expand its transmission grid to a meaningful degree? And if so, how much will it cost?
If I had the answer to that, Robert, I'd be making a lot more money. No, no, I think your point is salient, right? Building transmission is an incredibly challenging effort. Putting generation in local pockets is comparably challenging. And so I think the system we have is what we're dealing with. I know that even the interconnection process for California right now, they call it a cluster process. I think that's aptly named. I'll just leave it at that.
With another adjective coming after cluster, would that
no,
be?
I mean, in fairness, having worked with the people that are working through that process, it is challenging because their goal is to say, we need to bring this generation online, but we need to do it in a safe and reliable way that's not going to bring down the rest of the power system. And, when you've been working with systems and processes that are built for bulk power, studying 10, 15, 20 projects in a given cycle is doable. It's feasible. They're into the hundreds now. That process needs evolved. FERC, all the ISOs, ERCOT included, they've all recognized the interconnection process is a challenge and it's becoming a bind. So trying to figure out how to evolve that to say we're getting more smaller distributed resources online and we need the similar reliability to protect the bulk power system is very challenging. I don't envy their jobs.
Well, I've talked to many people and I've written about the high voltage transmission issue because it seems like this is one of the binding constraints on the entire system, right? And thinking about the system as a system, right? It seems to me that the networks that we have now, whether it's the electric grid or the power or the gas grid or the liquid fuels pipeline network, we're not going to see radical expansion of any of those because of the land use constraints.
No,
so, I mean, do you agree with that?
Yes. I mean, when I started studying energy, again, I'm old enough now. I remember looking at the idea of, can we use financial transmission rights to incentivize transmission buildouts? And similarly to LMPs in an energy market, it's kind of that field of not good dreams, which is, if you build it, they will go. Like, how do you get them to build up enough to eliminate the scarcity? And so
I want to interrupt there because you use some technical terms though. So you're talking about high voltage incentives. You're saying you would pay landowners to come across their property based on the amount of energy through the wires?
No, I apologize, Robert. This is an older term from early 2000s, which is to incentivize investors in transmission. They will pay you based on a transmission right, how much flows across your power line, how much congestion you alleviate. We'll give you compensation based on But the more transmission you have, the less congestion you have, the less incentive you have to build. And so what you do is you use up some of those limited right of ways for transmission, as well as limited property for generation. So if I have local need, I have high prices in, Dallas, Fort Worth. If I build too much generation there, the energy prices will tank. And those prices I was basing that investment on are gone. And so trying to, again, assess how you want to build in those limited spaces and what your value proposition is if you eliminate that scarcity.
Okay, so but you're only talking about incentivizing the people who are building the wires, and then you use the term LMP. Explain that, please.
Oh, apologies. LMP is locational marginal price. So that's just the price of producing the next megawatt hour of energy at a given location.
Okay. Right. So again, these are all based on, it's all about geography, right? Where is the power being produced? Where is it going? And how much is available? How much is demanded, right?
Yep.
So the LMP, the local marginal price, locational marginal pricing, determines where it's dear and where it's cheap, right? So but that all depends on transmission. So getting back to California, is California unique in this regard? I know you were there for a long time. Now you're working across the country, and we've heard over and over from, different, and I've written about the difficulty of building high voltage transmission. There are numerous studies that have been done that say, oh, well, we just need to double the rate of high voltage transmission or something like that. Is that feasible, that we would see a rapid increase in the build out, even if we saw some kind of permitting reform bill in Washington, that we would see a rapid build out of the high voltage system?
No. I mean, everywhere you've listened to, FERC commissioners are pretty candid about the need for additional transmission siting reforms and the like. Permitting aside, the cost of transmission is still very high. The time lag and permitting processes is not just a federal issue. You still have to deal with local areas. It is extraordinarily complex record. It's unnecessary enhancement. I think it's something that we need to continue looking on. I'd hate to think that we're going to try and continue moving forward with new generation technologies with 50 plus year old, transmission system. We do need to figure out solutions to it. In the short term, though, it is going to continue to be a bottleneck.
And when you say short term, does that mean 10 years, 15 years? Because these projects I wrote about, Transwest Express, Bureau of Land Management just said that they gave final approval to one part of it, but there are people in Wyoming promising litigation over this. And Transwest Express has been pending now for 12 years, something like that. Grain Belt Express, a similar kind of timeline. So I'm saying these because you're underscored that this is not, it's not just a federal issue. You have the states, you have the counties, you have even the municipalities and the landowners, all of which are going to have to say, oh, sure, we want these 200-foot high, pylons on our property or across our county. Yeah. Is that what you're referring to?
So short term, I think anything planning related in energy, you're really talking 10 years. I think that's.
So a decade is short term.
That's kind of how I look at it.
No, I'm not pushing back. I think that sounds reasonable to me.
Yeah. Integrated resource planning processes typically look out 10 years because that's about the best that you could hope to see. You can claim perfect foresight to 2050, and I think those studies are necessary and helpful from a planning process. But I think, the reality of getting things built and done, 5 years is in some instances doing pretty good. For transmission, you're right. Those time horizons, those 12, 15-year time horizons for long bulk powered lines, probably not an unreasonable estimate.
And if that's the case, I'm not joking here, but it might as well be for, forever, because the capital is going to have to wait around that long. You're going to have to very patient capital, very patient systems in place, regulatory networks, et cetera. But bring it back to Wärtsilä. Does this then bode well for your technology? Because you could put it pretty much anywhere, right? As long as you have access to high voltage transmission, you don't need water. You need the gas pipeline, right? Or maybe you don't if you're going to run it off diesel fuel, which would be more expensive, right? But you've
Mhm.
got a more flexible, I'll use that corporate term, solution that you can deploy where the load is and not have not necessarily have to contend with these other constraints on transmission and distribution. Is that am I? I'm not trying to join your
Yeah.
sales team here, but does that ring true to you?
Well, every generator on the system has to deal with the congestion around it.
Yeah,
So there is going to be, those limitations, but as far as where you see variability, we can be there to balance it. So I think that's one of the important things. Like, yes, we need access to the natural gas pipeline and the bulk power system, but that's really about it. We can, provide that flexibility. So if things need balancing in West Texas, or things constrained at that West Texas interconnection, we can be there to pick up where wind is not able to get through that transmission, or be there to balance it when it drops off on that transmission.
gotcha. Well, you mentioned West Texas. One of my guests recently was Scott Sheffield, who's the CEO of Pioneer Natural Resources.
Mm-hmm.
The Permian Basin is woefully short of electricity. Are you going to put some power plants out there? Was that a good opportunity for you?
We sure hope so. We're very active. I think when you look at the markets around the country for places that our technology is just, if you were to ask where the perfect fit is, I don't know that you could ask for a much better place than what Texas offers. The variability, the access to transmission, the permitting processes are as clean as you're probably going to find in the U.S. We just see that need and that benefit down in Texas very clearly. So it's been a big focus for us lately. We've been tracking the ERCOT market redesign and the actions happening in the state legislature as well. And so we just think Texas is a great place for our technologies, especially as the wind and solar continue to increase in penetration down there.
And as West Texas, and more specifically the Permian, then the best of the best in Texas because of the move to electrify a lot of the drilling out there and the pumping needs, the demand for power out there. Is that one of the areas where you're prospecting? Then is that fair to say?
I don't want to reveal any trade secrets here.
Okay, fair enough. Well, so we've been talking for nearly more than 45 minutes. My guest is Karl Meeusen. He's at Wärtsilä. He's the Director of Markets, Legislative and Regulatory Policy at Wärtsilä, which is a large Finnish company based in Helsinki with revenues of, what was it, nearly 6 billion euros last year. So I don't know what my math on that would be, 7 or 8 billion US dollars. You can find more about them at wärtsilä.com. So, Karl, I always ask my guests, they introduce themselves, and then I ask, what are you reading? What books are on your list or on your desk or nightstand?
Well, let's see. I have the CAISO's latest transmission planning process update on my desk right now. I have a lot of Texas legislation on my desk right now, and a lot of trade.
You know how to party. There's just no.
I joke around, and you ask to a little bit about us. I think my team, one of the things that makes this job fun is we are energy geeks, and so when we're looking through things, it's really looking at models and numbers and data and analytics. So again, I know that I think I'm trying to remember, there was just a new report came out on levelized cost of energy that I'm checking out right now. So again, it's not exciting, full novels and literatures about what happened in Enron, or more recently in some of the pipeline infrastructure battles that have been going on. It really is looking at models and some of the interesting studies that we've been putting out. So I wish I had a more relatable piece to talk about, but it's really about some of the studies that we're geeking out on right now.
So no Tom Clancy novels.
Not recently, no.
Okay, fair enough. So my last question for you, Karl, what gives you hope?
What gives me hope is I think that there is a solution-based mindset out there. Whether you want to agree with the environmental policies that some states put out there or not, one of the things that I have hope for is that people want to maintain reliable, affordable, dependable energy systems. And even when you disagree, you can always come back to and look at the ISOs, RTOs around the country, say they need to keep the power on. How do we help them? And I think there is a renewed focus on that. It's not just we need to hit these policy goals. It's how do we evolve the system in a cost-effective and reliable manner? And that reliability piece, after 10 years at the ISO, I cannot look at a power system and not ask, what will ERCOT need to run this? What will SPP need to run this system? And I think that for better or for worse, the events, when California had rolling blackouts a couple of years ago, when Texas saw Winter Storm Uri, they illuminated challenges and a return to talking about reliability. That gives me hope, because that's what I want. I want a system that is there for everybody, providing affordable, reliable, dependable electricity.
I can definitely agree with that one right there. So we'll stop at that then. My guest has been Karl Meeusen. He's at Wärtsilä, the Finnish company, wärtsilä.com. You can find out more about them. He's the Director of Markets, Legislative, and Regulatory Policy at Wärtsilä. Karl, thanks for your time. It's been very interesting to catch up on auto cycle engines, which I'm an energy geek, so I love to talk about spark cycle, diesel cycle, and all of that other stuff. So it's been great fun to talk to you. Thanks for coming on.
I appreciate your time, Robert. Thank you so much.
And for all of you in podcast land, tune into the next episode of the Power Hungry Podcast. And when you do that as well, check out my Substack, robertbryce.substack.com. Until the next time, thanks a lot. See ya.